Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 24, and this problem asks us to determine the steps involved and outline the steps involved in synthesizing the tetrapeptide alanine, leucine, isoleucine, glycine using the Merrif synthesis. So the Merrif synthesis is a little bit different from what we've been doing thus far, such that before we were starting always from the N-terminus working way to the C-terminus, but in the Merrif synthesis, what we do is that we actually take the C-terminus, the very last amino acid, we take that and we attach it to some sort of polymer. So you can say this is the polymer, and we attach that C-terminus through this carboxylic acid onto this polymer. And now from here, we will keep adding on amino acids from the C-terminus until we reach the beginning N-terminal amino acids. So the steps involved is that what we need to do is that because we have the free amino group here from the first amino acid, we need to make sure that no other amino groups will be reactive. And the way we can do that is by protecting them using FMOC. So FMARC is a protecting group that is specific for amino groups and is very useful in organic synthesis, but we need to FMARC protect all 4 of our amino acids. So the general method for FMARC protection is you'll have your NCC backbone, and then you have your R group, and then you simply add FMOC chloride and sodium carbonate and water, and now you're going to FMARC protect your N-terminus. For any general amino acid. So now we need to add glycine, being the first amino acid, to our polymer. So what are we going to do? Well, we'll take our FMARC protected glycine, add a base to deprotonate this carboxylic acid to make that oxygen nucleophilic, and add the polymer with 1 carbon linker and chlorine group. So what we're going to get is polymer, carbon, and then the carboxylic acid, and our glycine, FMARC protected glycine. Now from here, we can start adding the additional amino acids. So this is glycine. So next we can add the next amino acid, which is going to be leucine, isoleucine, sorry. So isoleucine, what we need first to do is add pyridine, which is a base. We'll add pyridine, and then the second step we'll add the amide coupling agent DCC that we used in previous examples, and our FMOC protected leucine. So we have 1, 2, 3 carbons, 4, so this is leucine. Sorry, the third amino acid is isoleucine, so we need to add isoleucine. So this is isoleucine. So remember, we're going from C to N-terminus, so we add a glycine. Next one is going to be isoleucine. So from here, we'll have still the polymer, that carbon linker, and then our carboxylic acid of glycine. And now we added isoleucine, FMOC protected isoleucine, 1, 2, 3, 4. So now we have isoleucine. So now we need to add the next amino acid, and that is leucine. So here we just add the same steps. So do the same steps over and over again until we make our entire amino acid or in our entire polypeptide. So first step, we add the base pyridine. Second step, we add the amide coupling agent DCC, and as well the next amino acid being the FMOC protected leucine. One, two, three, leucine. And now we're going to make now the tripeptide being the polymer, carbon linker, and the carboxylic acid of glycine, and then the amide bond going into isoleucine, and then the amide bond going into leucine. And leucine is going to be FMOC protected. And last but not least, we're going to add the last amino acid for this polypeptide being alanine. So first step, just like before, pyridine, the base. And a second step, the amide coupling agent DCC, and as well the FMOC protected alanine. And now starting from the C-terminal amino acid from the polymer, we have the carbon linker, then glycine. And then from glycine, we go to the isoleucine. And then from isoleucine, we now go to the amide bond of the last amino acid, alanine. Remember, alanine is still going to be FMOC protected. And now what we need to do is we need to free this polypeptide that we synthesize from the polymer and from the FMOC protecting group. And how we can do that is, well, FMOC is base labile. So the reason that we add this pyridine group is to cut off the FMOC group. So FMOC is base labile, so we add pyridine before each step to remove the FMOC group, so we make the amine reactive so we can react with the new incoming amino acid. And in order to hydrolyze the C-terminal off the polymer, we need to add an acid, so a very strong acid. So in the first step, we'll add pyridine, take off the FMOC. And then in the second step, we'll add a very strong acid, hydrofluoric acid, to cleave, to hydrolyze essentially our carboxylic group off the polymer to give us our free polypeptide being alanine, NCC, remember, leucine, isoleucine, glycine.